today we are going to discuss about coordination compounds part 4. In that we are going to discuss low spin or inner orbital complexes, high spin or outer orbital complexes. What is low spin or inner orbital complexes? We can go through the example. For example, FeCN taken 6 times minus 4. This is ferrocyanide ion. Here cyanide ions are there in the complexes. This is a ligand. We have to call cyano. So that's why it is hexacyano ferrate 2 complex. Hexacyano ferrate 2 complex. In this complex, iron having plus 2 charge. In free iron atom, outermost cell electronic configuration 3d6 4s2. In 3d orbital 6 electrons, 4s2 electrons are there. So here 2 electrons, 1, 2, 3, 4, 5, 6. Here 2 electrons. In complex, here iron having plus 2 charge. So that's why it loses 2 electrons. From 4s orbital, it loses 2 electrons. So that's why 4s is now vacant. After formation of complex, here electron rearrangement takes place. Why electron rearrangement takes place in this complex means here ligand is a strong field ligand. Here repulsive forces between ligand electrons, and then metallic electrons means d electrons more and more. So that's why repulsive forces increases. That's why d electrons rearrangement takes place. Here 4 unpaired electrons are there in plus 2 state. 4 unpaired electrons are there. These 4 unpaired electrons, by the force of cyanide ligands, these are rearrangement takes place. Here 4 electrons rearranged like a pairs. These are paired up like this. So here 2 empty orbitals are there in d orbitals. D subshell 2 empty orbitals are there now. So dxy, dyz, dxz, dz square, dx square, y square. 2 orbitals are empty is there in this. How these empty orbitals came? By the rearrangement of electrons by the force of strong field ligands like cyanide. So here 2 empty orbitals and then 4 is also empty, 4p also empty. So these 2 orbitals involved in the hybridization. This is 2 d orbitals, this is d2, next s orbital and then p orbital. So that's why it is a d2 sp3 hybridization. So that's why it is a d2 sp3 hybridization. Here these empty orbitals filled with ligand electrons. Here 6 ligands are there. These are filled with ligands. Here also filled with. We know ligand means it can donate one electron pair to the central metal atom like this. So that's why low spin complexes mean inner orbitals involved in the hybridization. Like this, inner orbitals are involved in the hybridization. So that's why these are low spin complexes are inner orbital complexes. Inner orbital complexes. Inner orbital complexes. Now we are going to discuss about high spin or outer orbital complexes. For example, hexachloro cobalt, cobaltate 3, cobaltate 3. Here, chloro ligand, chloro is a weak field ligand, weak field ligand. Here, electronic configuration, outermost electronic configuration in cobalt 27, 3d7 4s2. Here oxidation state of cobalt is +3. So that's why cobalt loses in the complex 3 electrons, 2 electrons from 4s orbital, 1 electron from 3d orbital. So here 4s is 0, empty, 4s having 0 electrons and 4p empty, 4d also empty. Here no electron rearrangement, will be. Here chloride means Cl minus, ligand is a weak field ligand. Here electron repulsive forces in between ligand electrons and then metal electrons is less, so that's why here no rearrangement of electrons. Here no that much of force to pair up these electrons, so that's why these unpaired electrons like that only. Next, so that next 4s, 4p and 4d electrons involved in the formation of complex hybridization, formation of complex. So that's why it is involved in sp3d2 hybridization. Here d2d orbitals, 3p orbitals and then 1s orbital. So that's why sp3d2 hybridization. These are outer orbitals, not inner orbitals, not inner orbitals. These are outer orbitals. So that's why it is a outer orbital complex. Outer orbital complex. Why outer orbitals are involved in the complex formation means here chloride ligand is a weak field ligand. Weak field ligand. There is no repulsive forces between metal electrons means the d electron means the d electrons and ligand electrons. That's why no rearrangements. So that's why next outer d orbitals involved in the complex formation. Here we have to observe like this. This is an octahedral complex. Octahedral complex. Here 6 ligands approaches towards metal atom. Here metal atom from 6 directions. When these ligands approaches towards the metal atom, at that time d orbitals can split into two types. Those are T2Z and then easy in octahedral complexes. At that time, if strong field ligand is there, splitting is more. Strong field ligand is there, splitting is more. If weak field ligand is there, splitting is less. Energy gap between T2Z and easy. Here gap is more, here gap is less, makes here ligand weak. Here no rearrangement. Here rearrangement will be. Here ligand is strong field. Ligand is strong field, so gap is more. So if ligand is strong field, at that time low spin complexes or inner orbital complex formation takes place. If ligand is weak field, at that time high spin or outer orbital complexes formation takes place.